Well, viewers, of course, we'll keep a close watch on what happens at the Supreme Court. But now it's, of course, time to talk about India's ambitious mission to the sun, the Aditya L1. The countdown has begun, of course, for the launch here at Satish Dhawan Space Station, where I'm standing at. At the moment, of course, you can see the visuals on your screen coming in, all the preparations in full swing. The scientists say they're ready. Now, at this point in time, this, of course, comes at the heels of the success of Chandrayaan-3, especially the soft landing that was evasive last time around. The scientists at ISRO making the entire country proud with what they achieved. But now it's time for a new mission, a new challenge. The distance this time around, of course, is 4 times than what the earlier satellite, that is the satellite carrying the lander and the rover, had to really traverse in space. This time it'll have to do 4 times that, and that's where the challenge really lies, going in towards the sun, and multiple experiments, of course, lined up. Now, before, of course, we talk more about this, I have a guest joining us today. We have, in fact, Sasikumar Kantepalli, scientist. He is, of course, with the Aditya L1 mission, worked on the VELC payload from the Indian Institute of Astrophysics. We also have Mr. Suresh Naik, former group director, ISRO. Before I go to them, I believe the chairman of ISRO has just spoken about, the launch tomorrow. Let's listen in first.
The countdown for PSLV C57 Aditya L1 mission is starting, and tomorrow noon time we will have the launch. That's at 11:50. Then it will take almost an hour for the satellite to reach the required location and inject. So the Aditya L1 satellite is for studying our sun, and it will take another 125 days to travel from Earth to reach the point where the satellite will look at sun, called L1 point. So I came here to pray to Changalamba Parameshwari for getting us the strength for making this launch again. Very important launch, successful. And thank all of you for being with us during Chandrayaan-3 launch as well as for the launch of Aditya L1.
Well, let me immediately go across to my guests who are with us, Mr. Suresh Naik, a former group editor from ISRO. Sir, if you could tell us how important is this particular mission, because we've already imprinted on the moon and now we are getting that much more closer to the sun. Studying the sun, of course, is going to be vital. Break it down for our viewers about this mission in itself and, how much preparation has gone into it.
Yeah, actually, you see, it is a very important mission. First mission of India or ISRO to send a solar observatory in space to study sun in greater detail. And the important thing is a multi-spectrum satellite. That means it is going to carry out study of sun, solar activity, magnetism, as well as the particles emanating from sun in various bands. One is visible and infrared. There is one payload which is looking at it. Second payload looking at the sun is ultraviolet spectrum. It is going to study. Third one is low energy X-ray. Low energy X-ray, that is another spectrum. And fourth one is high energy X-ray. That is going to be the 4 payloads. These 4 payloads are going to look at sun. And there are 3 more payloads on this satellite, which are going to study the L1 point itself. Now, let us come to the technological aspects first. We are going to put a satellite in a halo orbit around L1 between the sun and Earth for the first time. And it is going to be a challenging job. You see, this is 4 times farther than moon, so it is going to take 4 times more. In case of Chandrayaan-3, we took 1 month, let us say. Here we are going to take 4 months to reach the halo point, which is 1.5 million kilometers away from Earth. Now, first, the satellite will be launched in an Earth orbit, which is a normal orbit of, let us say, few thousand kilometers above or farther away from Earth, and few hundred kilometers or 170 kilometers, 80 kilometers closer to the Earth. Afterwards, the apogee point, which is the farthest point, will be raised in Earth orbit itself, maybe 3 or 4 times. And then when it is at perigee, that firing will be done so that it gets a velocity of 11.2 kilometers per second, or in other words, 40,000 kilometers per hour. And that is how it starts its journey beyond Earth's gravitational influence to Sun. And then it will take, let us say, 4 months approximately to reach the L1 point. Now, you see, putting it in the hollow point orbit is extremely challenging, and it requires very deft maneuvers from the mission control, and it is harder to maintain that orbit there. That is the point where the Sun's gravity and Earth's gravity, they are balanced out, and that's why it remains a stable point. But there is no planet around which you can keep it revolving. You see, if there is a planet there, then the advantage will be the planet's gravitation force will acquire it. It will catch it in its orbit if we slow down its velocity. But here there is no planet, so we have to play around with Sun's gravity and Earth's gravity and achieve that goal. Now, another important thing here is if you put your satellite in the L1 point in the hollow orbit, then there is not going to be, eclipse of the satellite created by Earth. That means Earth is not going to come.
You continuously, of course, can take a look at the sun, continue to do experiments, nothing to block the vision at all. Let me also bring in Dr. Sasikumar Raja. Sir, if you could tell us, Doctor, here, because if you consider the 7 payloads that are on board Aditya L1, one could probably say that VELC is one of the more important ones. Take us through this particular payload's importance, what it's going to be studying, because as far as building of this payload itself is concerned, and also the tie-up with ISRO, I believe is at least a decade old.
Yeah. Hello, good evening. So the visible emission line coronagraph is the prime payload. So it is basically the coronagraph. The coronagraph means we have to observe the solar corona, that is outer layer of the sun. Basically what happens, the corona can be observed from ground only during total solar eclipses. So during total solar eclipses, when the moon blocks the photospheric disk, we could able to see the corona. Otherwise, the photospheric disk light is so bright, and the coronal light is so weak, we could not able to observe them. So now, since we are going to the L1 point, we could able to observe the solar corona for longer duration. During solar eclipses time, what happens is total solar eclipses are very rare, and it occurs at different location for a shorter duration, for example 5 to 10 minutes of time, and solar corona has long standing mysteries, and this time is too small. That's why we are setting the visible emission line coronagraph that can create the artificial solar eclipses, so that we could able to observe the solar corona 24/7. And
Doctor, one thing I want to really bring to the notice of our viewers is the essence of this study, because I was speaking to the principal investigator of this particular mission a couple of days earlier. Even he was pointing out that the study can actually prevent some disasters on Earth. If you could take us through what is that, and especially we can even protect our satellites is what we've been told from studying the sun, because many of our viewers would be wondering, what are we really going to learn from studying the sun? Is it going to come in handy, or is it just some fancy experiment? So take us through the nitty-gritties of that.
Yeah. So what happens is you mentioned about the space weather. See, what happens is there are like transient emissions like coronal mass ejections, which are like, it's a huge bubble of mass, approximately 10⁻12 kgs of mass ejects outward in 1 CME. During solar maximum, which we are currently now, it will per day we may expect 6 to 7 CMEs. So if such CMEs propagates towards the Earth, and then there it compresses the Earth's magnetic field and can cause the geomagnetic storms. And also, you might have heard the beautiful green light auroras. And such compressions can cause the radio blackouts, as also it can disrupt the power grids, and telecommunication radio blackouts can happen, and military radar jumps can happen, and also because so many spacecrafts are there, so these can because of the CMEs and the particles, if they directly hit the spacecraft, they can malfunction, and sometimes they can fail as well. So, and it can cause hazardous to the space travelers like astronauts and the avionic pilots, etc. So these are called space weather. This is one of the prime things. So what happens is visible emission line coronagraph, it can observe the CMEs very close to the solar disk, so that we could be able to study the
Dr. Sasi, I want to ask a quick question. I want to ask a quick question to Mr. Naik before we wrap, because I'm running short of time. You know, behind me, we have all the rockets that have been built by ISRO, and also, of course, the PSLV Mark III. So, Mr. Naik, if you could take us through, this particular rocket that's going to be taking Aditya L1 tomorrow, launching it from Earth. How important is this rocket? Because it's had multiple successful launches, isn't it?
Yeah, actually, we see this time we are going to use PSLV rocket to take the Adityan to its destination, and not the GSLV Mark III, which was used for Chandrayaan 3. The main reason for that is this time the mass of the satellite is low. It is hardly 1700 kg, and that can be handled by PSLV. On the other hand, PSLV is a low-cost flight compared to GSLV Mark III. It may cost only about 110 crores per flight, as against 300 and odd crores for GSLV Mark III. That is because the fuel which is required for PSLV is much less compared to GSLV Mark III. And that is the main reason. And we don't have to unnecessarily spend money there in the rocket, and we are saving money. Second thing, see, PSLV has done almost more than 50 successful flights. I think it may be 60 also. So in terms of our assurance about its reliability is far more than GSLV Mark III, which has got to its credit about 6 to 7 successful flights. So these are the two main reasons why we are using PSLV. And PSLV is our sure shot launch vehicle. So we do not have any possibility of having a failure during the launch itself. And after that,
absolutely, Mr. Naik. Thank you for sharing your insight. Unfortunately, I'm out of time. I thank both our guests, Dr. Sasikumar and Suresh Naik, for joining us. Now, in just a few hours from now, India, of course, will embark on its solar journey. And I will, of course, be right here at the Satish Dhawan Space Station at Sriharikota to bring you all the updates as and when it happens, only on Mirror Now. So do stay tuned, of course. We start our coverage as early as 7 tomorrow. So don't, of course, miss out on everything that's happening here at the Satish Dhawan Space Station in Sriharikota.
After conquering the moon, ISRO is all set for Mission Sun.
We have achieved soft landing on the moon.
Aditya L1 is ready for launch.
The rocket and satellite is ready. We completed the rehearsal for the launch.
India's Space Quest. Live and continuous coverage only on Mirror Now.